In order to establish beyond all doubt that an aircraft and its equipment are safe and efficient, they must be extensively tested and explored to the limits of their performance. To evaluate a completed aircraft for service use against the many and complex requirements laid down for it calls for the specialized skills of a closely knit team. The engineer, the scientist, the test pilot. Modern instrumentation records much of the quantitative data during tests, but the pilot will always be needed to make the all-important qualitative assessments. How does it handle? Does it respond well? Is it easy and pleasant to fly? The pilot alone has the answers. He is the explorer or trailblazer who lays down the parameters that operational pilots must not exceed. What, for instance, does this test pilot feel about flying the Harrier?
Well, quite honestly, I found flying the Harrier more rewarding and exhilarating than even learning to fly. Mainly because of its tremendous acceleration, deceleration, and vertical takeoff and landing capability. The test program's been fascinating, and evaluating such a revolutionary aircraft has meant evolving new test techniques to define the operational limits. And although the aircraft has been released to service, our work still goes on.
Did you feel you were getting close to a limit?
Well, I don't think so, Peter, because the over-rotation was immediately apparent, and there seemed to be plenty of control power left to stop it. In any case, the higher incidence didn't seem to produce any handling problems whatsoever.
All the records show that there's no change in the slope of the trim curve at this instance, and I feel we can safely proceed with tests either at this instance or at a further RCG.
Well, I'd prefer, I think, to go for the tests at the higher incidence, but we'll have to be careful of crosswind, because if we have to correct in roll or in yaw, the drop in duct pressure may well cause a reduction in pitch control power.
It is sometimes imagined that performance testing applies only to new aeroplanes. This is not at all the case. As service requirements change, a new weapon to be dropped, or a rocket to be launched, another bit of kit to be incorporated, or an engine to be uprated, the specifications alter accordingly. And a modified aeroplane, however elderly its type, must be tested as stringently as a prototype. Tests might be necessary, for example, to establish the length of runway required, at much higher weights than originally called for, if the takeoff had to be aborted in an emergency situation. For test pilots, flying several different types of aircraft on any one day is a matter of routine. Obviously, such exacting and responsible work calls for specialized training to ensure that the necessary flexibility and techniques are not achieved at the expense of flight safety. This training is made available at the Empire Test Pilot School at Boscombe Down. Every test pilot in the government's research and development establishments is a graduate. The school's pupils are predominantly from the British services, but students are also accepted from Commonwealth and other allied and friendly countries. For this elite group of pilots, acceptance for the course at ETPS means a year of very demanding and intensive work. But for the successful graduate, the reward is commensurate with the effort. The CO puts it this way.
Our students must have an operational outlook, because at the end of their training, they'll be responsible for evaluating the operational equipment for the armed forces. So we give them responsibility here right from the start. We expect them, in a very short period of time, to convert to a wide variety of aircraft types and to carry out some very demanding handling exercises. Obviously, we monitor this process closely, but the onus for the planning and conducting the flying lies with the student. It's the most rewarding year's flying in any pilot's career. It fits him for the challenge of the test flying appointment, but also for the top flying jobs, operational or test flying anywhere. And I do mean anywhere. Major Al Warden, the command module pilot of Apollo 15, he's a graduate of this school.
What are the essential qualifications that go to make a test pilot? The school syllabus leaves us in no doubt. High mental capacity, above average flying capability, character, courage, honesty, the ability to speak and write clearly. Most of these qualities must be inherent to the individual. Some come by way of experience, and others respond to training. The training and the experience are what the Empire Test Pilot School offers.
Gentlemen, I want you to remember that there are two main aspects to all testing: handling and performance measurement. And although for convenience, and to make it clearer for your reader, in your reports you will separate them, you must remember that they are interrelated, because they both build up to the picture of how did the airplane behave and what it was like to fly. Quantitative and qualitative evaluation.
Any movement in pitch is sensed as a voltage change in a pickoff. The signal is then processed by the attitude and autopilot systems and is finally fed to the control surfaces, returning the aircraft to level flight.
What happens if the platform has a random precession like that?
In that case, the precession is sensed by gyroscopes on the platform, and the signal is passed to the talker, returning the platform to level flight.
Okay, Rod, we've now had a look at the autopilot working in the normal sense and how that pitch inputs are damped by the autopilot. Now what we've done is alter the gearing of the autopilot so that its responsive pitch is much greater. We've made it a higher geared autopilot. And what I'd like you to do is put a pitch input into the aircraft with the autopilot in and see what happens. All right then? You have control. Are you quite happy?
Yes, I am.
Okay, off you go then.
Okay, starting now.
And you can see now that the aircraft has started to oscillate on its own. There's no sign of damping. And the only way we can stop that oscillation is by cutting out the autopilot and taking over manually. Okay?
Showed up very well indeed.
Quite exciting, really.
So the purpose of this test is to determine the pressure errors of a test aircraft, a Canberra, which you will be flying, Krish. And to do this, we'll compare it with a calibrated aircraft, the Viscount, which you will be flying, Pete, which has a very accurate measurement of its height and speed. So the whole exercise demands extremely accurate flying and observation. Now, your aircraft's limited to 220 knots, and you're required to fly past it, level, at 3 spans distance, at 450 knots. And at exactly the moment of passing J's ray, you record the reading on your aneroid. That clear?
When I fly past the Viscount, how do I ensure that I'm flying absolutely level? Do I have to refer to the instruments at that stage?
No. The easiest way is to place the Viscount on the horizon, stabilize the instruments in your own aircraft, and then keep the Viscount on the horizon up to the moment at which you fly past it.
Stand by. 5, 4, 3, 2, 1, now.
Right, now that we've again compared the aneroids, you can calculate your results. They must be accurate. For example, in the case of instrument letdowns, safety minima will be established on the basis of the pressure errors determined.
The NACA pull-up test method will be used to obtain some measure of the maneuver stability of the helicopter at various speeds throughout the envelope. Continuous trace recording equipment will be used for these tests. From trimmed level flight, the cyclic stick is moved sharply aft and the input held for a minimum of 3 to 4 seconds. AFP 970 requires that the input should be sufficient to produce an increase in normal acceleration of 0.3 g within 2 seconds.
To summarise, as helicopter pilots, you're all well aware that for much of the speed range, a helicopter requires less power for straight and level flight than it does for an OGE hover.
Okay, signal. Right, you're lifting now. Right, you're coming clear. Forward 1 foot. 5 feet to go. Forward 2 feet. Steady. 3 feet to go. 2 feet to go. You're on top. Shackle just coming up now. Weight is on. 200. You're over the top. Go back slightly now. You're drifting forward.
Of course, tethered hovering is a high-risk trial. but it is necessary to find out data on the hovering performance of the helicopter in and out of ground effect under varying conditions of outside air temperature, height, and all-up weight in zero wind. This is essential data for reproduction in various forms in ODMs.
For case one, then, let's consider an aircraft flying wings level into the blackboard, with the starboard engine running and the port engine stopped. In plan view, it'll look like this. And of course, we'll have starboard rudder applied. What yawing moments are we going to have then?
The obvious one due to the live engine.
Sure. What others then?
There'll be a yawing moment due to the rudder.
Yep. But the force that produces this yawing moment due to rudder will give us a side force on the aircraft. And how are we going to overcome that side force, John?
Well, that will have to be overcome by a side slip to the left.
Sure, so we'll be side slipping to the left. But what's that going to do to our balance of yawing moments?
Well, now we'll have a yawing moment due to the side slip.
That's right. And with wings level, you now establish the minimum speed at which you can control the aircraft safely under asymmetric power. When you come to make recommendations, you must take into account such factors as average pilot performance, crosswind and weather, etc.
An aircraft's handling qualities are assessed during the approach, landing, and landing run. Additionally, a large number of landings have to be measured to obtain the actual landing distance. And of course, this will vary according to the prevailing conditions. Accurate measurement and correct assessment require a lot of experience and very accurate flying. And whereas you should always adhere to the laid-down vital actions, there are certain exceptions, in that you must cater for pilots taking off with the trims misset, particularly on an aeroplane where the trimmers are very powerful and trimmer positions aren't well marked. And so, under your tutor's guidance, you will, during this exercise, go outside the normal brief of observing all the aircraft's vital actions, and you will include in your handling tests takeoffs in the out-of-trim condition.
Note that the mass is concentrated in the fuselage as it is in current high-performance aircraft, a high B/A ratio. As the rate of roll is increased, the inertia moments will grow rapidly, eventually overcoming the aerodynamic moments, here represented by the springs, leading to divergence in yaw or pitch. We are required to measure whether the aeroplane meets the laid-down requirements in terms of rate of roll. This is of obvious importance to a combat aircraft. Roll damping varies, and we measure the rate of roll at different heights and under different G loading.
Dutch roll may limit an aircraft's weapon aiming capability, or even the ability to make a safe approach under instrument conditions. It's a classic example of the interrelation of directional and lateral stability, which must always be considered together. They can never be considered in isolation, as is longitudinal stability.
Although many of the
Test pilot training has an international background. Exchanges of staff and students regularly take place between the Empire Test Pilot School and the Test Pilot Schools of France and the United States.
Spinning is one flight regime in which even operational pilots seldom find themselves. However, when this does occur, they need to have accurate and concise information on their aircraft's spin and spin recovery characteristics. Consequently, as test pilots, we need to, one, determine that aircraft have sufficient natural stall warning to make inadvertent spinning unlikely, And in addition, we need to establish straightforward recovery procedures that are suitable for service use.
Well, what techniques will we be using for the erect spin entries?
During the initial investigations, we'll use the basic spin entry technique of inducing a yaw rate with the aircraft in wings level stalled flight. This will bring into play the aerodynamic and inertia forces that will eventually lead to our autorotative stalled descent. Of course, during the entire evolution, we need to remain alert under conditions of increased physical and mental stress.
So what can we expect during the inverted phase of the spin?
During the inverted phase, we'll find that the aircraft will be rolling opposite to the yaw rate. The rates of rotation will be extremely high, and of course the airplane will be in negative G flight. Careful attention to special instrumentation will be required so that we can sort out confusing sensory inputs and determine what the actual aircraft's behavior is, and consequently arrive at safe recovery procedures. Telemetry in this case provides a safety monitor. In case the airborne pilot becomes confused, the ground pilot can help him in recovery.
Ground pilot, tester 102, radio check.
Tester 102, ground pilot, you're loud and clear, standing by for checks.
Aileron central. Aileron full left. Neutral. Full right.
Roger, tester 102, ground pilot, ailerons checked.
Roger, elevators. Elevator neutral. Elevator full forward. Elevator neutral. Elevator full back.
Roger, tester 102 from ground pilot, elevators checked. Roger, tester 102 ground pilot, ready for checks.
Roger, rolling right. Rolling left.
Tester 102 ground pilot, airborne checks correct.
Tester 102, roger. Tester 102, entering. Ground pilot, tester 102. Next spin will be a normal inverted spin to the right from a left rolling entry. 3 turns, normal inverted recovery.
The Chipmunk exhibits a more conventional spin due to its configuration. Although the height lost is considerably less than the Hunter, the rate of rotation is rapid, and to observe all the characteristics and parameters required for a comprehensive spinning assessment involves a high workload, particularly if airborne recorders are not available and the pilot is using only stopwatch and knee pad.
Visits to research establishments and the aerospace industry provide invaluable practical knowledge of latest developments, plus an opportunity to question the experts. Several of the Concorde's test pilots are themselves graduates of the Empire Test Pilot School.
How difficult is it to judge height during the landing flare?
Well, it's not necessarily more difficult than a conventional aircraft, but it's slightly different because of the very large pilot eye to wheel height, about 38 feet, which is due to the large pitch attitude of an airplane like Concorde on the approach. And this necessitates that the pilot makes a little bit more use of the radio altimeter in the initial few landings so that he can identify heights of 100 feet and 50 feet above the runway. Once he's updated his depth perception, he can make a pretty conventional landing without any trouble at all.
Leading experts in every branch of aeronautics lecture regularly at the school.
Now, we spent the first part of this morning talking about the aileron as the means of producing roll control. Now, you may ask, why does anybody want to replace the elegant and smoothly fitting aileron with this crude device, which we recognize as the spoiler?
Now, you met Reggie in the place, didn't you?
Students can also put questions to distinguished visitors to the school. Colonel Buzz Aldrin, second astronaut to step on the moon, is the CEO of the United States Air Force Test Pilot School.
Very enjoyable. We arrange things so that as the course progresses, the exercises increase in difficulty.
Right, I think we should eliminate these two immediately because they're very undergeared. And this is brought out well in the heading. There is no compensation for crosswind.
Yes, and number 10 isn't much good either. You see, it's overgeared, and you're getting this hunting around the localizer. It'll be uncomfortable to fly, and it'll be awkward to take over and land from the break-off height.
Yeah, well, in that case, we're left with number 6.
The final exercise, the preview handling assessment, is conducted on aircraft on which the students have had no previous experience. They are required, in 10 hours flying time, working in teams of 2 or 3, to perform a comprehensive handling assessment of an aircraft's suitability for its operational role. This is a realistic exercise. It's just the sort of thing they'll be doing in the future.
Operational pilots fly to the limit of their aircraft's performance. The test pilot establishes those limits.